Chemistry Class 8 Chapter 4 Atomic Structure Part 4 Stability of Atom and Modern Model of Atom Atomic Number, Mass Number and Isotopes by Bohrs.
Hello dear friends, today we are going to learn about the stability of atom and the modern model of the atom with some basic terms and concepts. So, structural stability of atom was not explained by the Rutherford. There were so many questions about the stability of atom. Like, if central part of the atom is positively charged and electrons which are revolving around the atom are negatively charged, after a time, why they do not fall on the central atom due to the force of attraction? But the Rutherford theory was not able to explain it. In the next coming time, the scientist Niels Bohr explained about the stability of atom. He stated in his theory that electrons are moving around the nucleus with the high velocity. As a result, they do not fall in the central atom. Here, the force exerted by nucleus is counterbalanced by the motion of the electrons. The force of atom's nucleus is inward and the moving electrons are exerting force outward. And this way, the force is balancing electrons and they are always keeping on moving around the nucleus. According to Bohrs theory, the electrons revolve in fixed orbits or shells around the nucleus at a very high speed, with each orbit associated with a fixed amount of energy. The electrons present in these shells neither lose nor gains energy until some external force is applied on it. Thus, they maintain their position. As a result, inward force exerted by the nucleus is counterbalanced by the outward force of the moving electrons, thus preventing the electrons from falling into the nucleus and making the atom structurally stable. Let us see now the modern model of an atom. Atom is made by the main three subatomic particles, namely positively charged protons, neutral neutrons and negatively charged electrons. Already we have learned their properties in the previous videos. Second, orbits of atoms. Electrons are moving in the circular orbit, which is the fixed path of electron. So this way, atom is divided in the two parts. The first central part called as nucleus of an atom, which is consisting of protons and neutrons, and the orbit or shell, which is an imaginary path through which electrons keeps on revolving, and they are consisting of certain amount of energy. The orbit which is closest to nucleus is having lowest energy and the farthest orbit has highest energy. Since these orbits are possessing energy, they are also known as energy levels. An atom is electrically neutral since it has the same number of protons and electrons, that are same number of positive and negative particles. Now we will move toward the next concept of the lesson, that is atomic number. The symbol of atomic number is capital Z, and we can define atomic number as total number of protons. Atoms of elements are distinguished from each other by this atomic numbers only. Each element has unique atomic number. No atomic number is repeated for the different elements. The next concept is atomic mass. Atomic mass is represented by the capital letter A. Atomic mass is defined as the total number of protons and neutrons present in the nucleus of an atom. From this, we can calculate number of neutrons present in the atom. So number of neutrons present in an atom is equal to mass number, that is A, minus atomic number, that is Z. Let us take few examples. Number of neutrons present in a sodium atom is equal to its mass number minus atomic number. That is 23 minus 11 equal to 12. So there are 12 neutrons present in the nucleus of sodium atom. Suppose X is an element, then its mass number capital A and atomic number capital Z we can write in the symbolized form. Let us come to the next topic, isotopes. So what is mean by isotopes? So isotopes are the atoms of the same elements with the same atomic number but different mass numbers. Due to the difference in the number of neutrons present in the center of the atoms, that is nucleus of the atoms. Let us study it with the example. Example of element hydrogen. The hydrogen atom has ordinarily one proton and one electron with no neutron in its nucleus. It means its mass number is 1 and atomic number is also 1, which is known as protium. The deuterium is the heavy hydrogen with atomic mass 2 and atomic number 1. Since the deuterium is consisting of one proton and one neutron in its nucleus, it is heavier than the ordinary hydrogen atom. The third is tritium. Tritium has two neutrons and one proton in its nucleus, and one electron is revolving around. Hence, the mass number of tritium is 3 and atomic number is 1. So these all are the isotopes of hydrogen. Carbon 12, carbon 13 and carbon 14. Chlorine 35 and chlorine 37. Dear students, let us learn properties of isotopes. The first property. Isotopes of element have same chemical property but different physical properties due to change in their atomic mass, like density, boiling point, melting point, etc. All isotopes of the same element have same electronic configurations since their atomic number is same. The number of protons and electrons are also same. As a result, their electronic configuration is same. From the discovery of isotopes, Dalton's atomic theory is proved wrong. As Dalton stated that atom is indivisible, but we know that atom is made of the three fundamental particles, protons, neutrons and electrons. The second statement of the Dalton's theory was every atom of the same element is identical. Here isotopes, even though they are of the same elements, but their atoms are different due to the difference in the number of neutrons.